Okay, A-Day, so since you got the snow day, we're a little bit behind compared to B-Day and our quarterly exams coming up. So we have two more topics, one being graphing, one being writing inverses. So this is called a flipped classroom. The notes are going to be here and the practice here. You're going to pause the video, you're going to kind of go through it, and we'll talk about graphing logs. So that's what this video is going to be about, going through the notes at home versus in class, and we can practice in class. So let's take a look. Exponential function, x is in the exponent. So if we did the xy table and we plug that in, 2 to the negative first power is 1/2, 2 to the 0 power is 1, 2 to the first power is 2, 2 squared is 4, 2 to the third is 8, right? So from there, let's plot those points and we'll take a look at this function. So negative 1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8, it's about here. So you can see this is exponential growth. And as we talked about before, it has a horizontal asymptote. The parent function does with no shifts at 0, okay? Horizontal asymptote there. Versus, this is the inverse, and we're going to talk more about that, where they switch the x and the y. Notice that's all they did. This is equivalent to writing it as a log, and we're going to talk about that, okay? So notice, if you're switching the x and the y for the inverse, that's all you have to do here, okay? So this would be 1/2, 1, 2, 4, 8. So you can see from both tables, I just switched the x and the y. So let's take a look here and plot these. So negative 1 and 1/2 be here. I'm sorry, 1/2 negative 1 would be about here, right? 1, 0, 2, 1, 4, 2, and 8, 3 is a little off. That's okay. This would be the graph of the inverse of that function. This inverse of that function, if we were to write inverses, like lesson, it says 6.5, but we did a different lesson for it. Remember, if we're writing a log, okay, then it would be log base 2 of x equals y. This is the inverse of that, okay? They are inverses of each other. This is the parent function, log base 2x, while this is the parent function of exponential 2 to the x power. Now, if you notice, let's talk about differences between them. When you have a log graph, it always contains this number, the parent function. This is going to be your starting point. Okay, as we shift graphs and talk about changes, that's this point right here, guys. Okay, that's going to always be from the parent function. It will always cross to there, unless you add numbers for shifts, and we'll talk about that. Notice, it also has an asymptote, guys, at x equals 0. This is vertical. So meaning, I'm going to go over my exponential graph. It is a vertical asymptote, not horizontal. For exponential graphs, it's horizontal. For logs, it's vertical. So again, not horizontal. So let's review the main points, okay, when it comes to a log, and then we'll use this parent function to start. So the domain of the logs is not all real numbers. Okay, that was exponential. Because there's a vertical asymptote, the x values stop at whatever your asymptote is, okay, whatever your asymptote is. So in this case, the domain is 0 to infinity. The range, however, here, okay, is going down forever and slowly up, so that's the all real numbers. The asymptote, which is always a vertical, I'll just put VA for vertical, in this case is x equals 0. There are no shifts, so we're not talking about that here for the parent function. End behavior. Now remember, going old school, this is what we mean by end behavior. So take a second and copy that down. That's what we mean by end behavior. Remember when we did the polynomials, we said the left side of the graph, when x is negative, what's happening to y? The right side of the graph, what's happening to x? In this case, we don't have to worry, okay, about negative because x is not getting negative, right? the asymptote here is at 0, so x is not getting negative. So really, we're going to focus on this side of the end behavior. We're going to focus on this side. So what this means is as x is getting bigger, see what I mean? As x is getting bigger, going to the right, what is the y doing? The y is going to be getting bigger. And the y is getting bigger because it's all real numbers for the range anyway. So these are the parent functions. So let's talk about when we get transformations, right? Good old h and k, guys. It's the same thing that you've been doing. Now here's the big thing. H tells us the horizontal movement, left or right. If it is a plus, it moves to the left. Remember, it is opposite. If it is a minus, it moves to the right. But here's the other biggest thing. It will always tell you your vertical asymptote. If you set the parentheses equal to 0 and solve, you get your vertical asymptote, okay? So set the parentheses equal to 0 and solve, and you get your vertical asymptote every time. Now, if A is negative, it's going to tell us that it's going to reflect, okay, or flip the graph, and we'll show you examples of that. And K, the last guy, remember, if K is positive, it means it moves up. If K is negative, it means it moves down. So we're going to practice these shifts first and kind of talk about the pieces of the graph and key features. So let's turn the page. All right. So first thing is, this right here is the parent function. So draw a line through the points. That is just there for your reference. This is the parent function. So for this case, it would be y equals log base 2x. Parent function, no shifts, right? Notice it still hits at x is 1. That's always going to be the case. Now, let's talk about the shifts before anything else. This means, okay, left 3. Now, what is that going to do? That's going to change your asymptote and your domain. Both of these together. Okay? The asymptote, you set that equal to 0. So the asymptote is at x equals negative 3. The domain is anything bigger than that number. So let's shift it first. Let's move the ordered pair. You ready? So in this case, we're moving this point. So each of these points, left 3. So I'll even use a different color. 1, 2, 3. Right there. 1, 2, 3. 1, 2, 3. So something like that. And notice this here, your asymptote is at negative 3. So draw a dashed line. That's your asymptote. This would be a picture of your shifted graph. All it did was move left 3, which again affects your domain. Your domain would be x is bigger than negative 3. Range, still all real numbers. And behavior is still going to be the same, okay? As x gets bigger, y gets bigger. Okay, we don't really have to focus as x gets negative because it has a stopping point at negative 3, so we don't emphasize the left side of the graph. Okay, so let's take a look at this example. This would be right 1 and up 3 for the shifts, right? This again controls your vertical asymptote. So again, vertical asymptote. You set that equal to 0. So my vertical asymptote is going to be at x equals 1. So that's going to go right here. There's my vertical asymptote, guys. Now, let's shift each of these points this direction. So right 1, up 1, 2, 3. Right 1, 1, 2, 3. Right 1, 1, 2, 3. So you can see here is going to be our new shifted graph. The domain matches the asymptote. The domain is from 1 to infinity. The range is still all real numbers. And the end behavior is still the right side of the graph. Y approaches positive infinity. Now let's take a look at when we have that a value in front, that a value is negative. Let's see how that affects it when the a value is negative. So here again, this is just the parent function, okay? If you want to sketch it, you can. It's up to you through the points. There are no shifts here, right? So we're actually not going to move these points, guys, okay? We're not going to move these points. So the domain is still going to be 0 to infinity. The range is going to be all real numbers. The asymptote is still going to be x equals 0 because there's nothing there. The only difference is, let's take a look at our end behavior, okay? Now, if this graph's going to flip, then it's going to look something like this, okay? So as opposed to going upwardly, it is now going to look more of going downwardly. Now, it's still going to have a vertical asymptote. I did a bad drawing here at 0, but it's going to slowly keep going really this way. So on the right side of the graph, as x is getting bigger, y in this case is actually getting smaller. And that's only if it is a negative, okay? And it flips it. Only if it's a negative and it flips it. So let's take a look at putting all of the pieces together. For this last one here, let's say this is 2 left, right? We know that it reflects or it flips. And then here would be 3 down, right? So first thing we're going to do is let's just do a sketch. Now again, this is the parent function. Let's do a sketch of the shifts and then graph what this is first before answering the questions. So I'm going to start here, move it left 2, down 3. Here, left 2, down 3. Left 2, down 3. Now, the problem with this is our asymptote is still going to be at -2, okay? So that's something. You set that equal to 0. There's going to be your asymptote no matter what. So I could draw that dashed line. But the graph is not going to go in the same direction as the original. It is not going to do that because it is flipped. So instead, it will come up more like this. So it's going to reflect over the x-axis. So instead of coming here, it's going to go here. Instead of here, it's going to go here. Okay, that's the idea. Left 2, down 1, 2, 3. Left 2, down 1, 2, 3. So it'll actually be, I should say, 1, 2. Here, should say, and then here, right? So this is really what the graph is going to look like. Okay, slowly going to go down and down. You can see that it flips, okay, from the original, that kind of thing. So the only real thing that affects is your end behavior, okay? The domain still is affected by the asymptote, so we say 2 to infinity. These still go together. The range is still going to be all real numbers for all logs. The end behavior, though, on the right side of the graph, y is going to slowly be going down instead of going up. That's the major difference. So, what I want you to do is there are several practice problems here, and here, and here, and here that I want you to try. This is your homework for tonight, okay? So your goal is to go through these, all right? And then I will have the answers posted to Google Classroom so you can check your answers and see if you have questions, okay? See if you have questions on them. Be prepared to ask. So again, replay this video, pause it, do whatever you need to do. Your homework is to try these practice problems The answers to these, again, will be posted to Google Classroom, so you can check right away what you did or did not do right or wrong. Okay? We will practice graphing on Friday in class. We will finish the scavenger hunt, and we will be talking about inverses, writing them, and how they look between logs and exponentials.